Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about how to calculate lambda max by using Woodward and the Fisher rule. And what are the essential thing required for the calculation of lambda max by using Woodward and the Fisher rule? So, first thing required for the calculation of lambda max, which is a base value. As we know that base value for dyne is only one, that is 215 nanometer. And once you know the base value, then and then you can calculate the rest of the thing accordingly, as we know that the general short form while calculation for the calculation of the lambda max based on Woodward and the Fisher rule. Let us see, we are going to take an example here, because what do you mean by the exocyclic, what do you mean by the Homo annular system, what do you mean by the extended conjugation, what are the substituents, if a different type of the substituents are there, how much nanometer to add in it. This type of the analysis or the total explanation we have learned in our previous lecture. So today, right now, we are going to solve the example based on this. Now look at here, I am taking an example over here. This one, this is the first example I am taking over here, the first example. Right? This is the first example. Calculate the lambda max by the following molecule. The question is like this: calculate the lambda max of the following compound, or following molecule. Calculate the lambda max of the following molecule or following compound. So see, this is one of the structure, or it is a compound. While solving a solution, so first of all identify the system. What type of the system? Look, if you observe this structure carefully, what do you see here? This is a structure. And now carbon-carbon double bond, single bond and double bond. Is it a dyne system? Yes, it is a dyne system. First you write it is a dyne system, right? That is the first one. If dyne system is present, then first one you have to write the base value. What is the base value for this? As I already told you, if there is a dyne system, only on one base value, which is 215 nanometer, that is the base value for it, dyne system, because we identified the dyne system. First thing to identify what type of the system it is. So this is the dyne system, or you can call it is a dyne system. That's it. Now next point, circle it or mark it like this, right? This is a dyne system. Now according to next one, E stand for exocyclic double bond, do you know that the double bond means what? If there is a ring present and observe that ring, see outside, is there any double bond present? If there is a double bond present, that will be the exocyclic double bond, but here is a no double bond, so no question of exocyclic. So no exocyclic at all. You write it exocyclic 0 or don't write it, it doesn't matter. So there is a no exocyclic. Homo annular system. And once again, you know that the Homo annular system also, in a previous lecture we know that Homo annular system, if ring is present and that ring contain the carbon-carbon double bond, and that double bond should be present alternatively in a conjugation position, then and then that type of the system is termed as Homo annular system. And here if you see this structure, it is a open chain structure, it does not contain as a ring. Therefore, there is no question of Homo annular system. So now you write it or you don't write it, is as it, so keep as it is. Then second E stand for extended conjugation. First, put the hand on that dyne system. Along with that dyne system, see, is there any extra double bond? If that extra double bond must be, if it should be in a conjugation, then and then it is counted. Otherwise, don't count it. So look at here only as a 2 double bond. 2 double bond means it is a dyne system. And therefore, in a first example, there is no question of extra double bond, means extended conjugation is not here at this particular example. Now is a substituent. Now how to count, how to identify substituent? Now look at here, this is if hydrogen atoms are there, as we know that we are not adding 0 nanometer you should add, but look at here, one stick is there, it means there is only one substituent is present. So you can mark it like this or you can label it like this, means there is only one substituent. Which substituent it is? It is a alkyl substituent, and therefore only one substituent is present. Alkyl substituent means one alkyl substituent. Alkyl substituent. How much to add? You should add 5 nanometer in it, and now that's it. So simple. Then you can see like this, and then simply add 5 in that base value, and here you should write lambda max. This is the lambda max, means wavelength. How much? If 215 plus 5, it becomes 220 nanometer. If you write like this, you will get as a 2 mark. So remember, in this way you have to calculate the lambda max. That is a calculation of lambda max by Woodward and the Fisher rule. I hope you might have understood. This is the first problem. Now let me take second example over here. Second example will be this one. Now I am showing here second example. So here let us see. This is the structure over here. Now observe this structure carefully, and what is our first things to do or first job to do? First thing, you observe the structure carefully, then recognize or identify whether there is a dyne system is present or not. Look at this structure, observe this structure carefully, then you will find Look at here, carbon carbon double bond, single bond, double bond, single bond, double bond. Means you can circle either this is one of the diene system or you can circle like this, right? So only one you can circle. Suppose if you circle one, so this is a diene system. Remember, this is a diene system over here. I am clearing this line over here so that you don't get confused here. Here it is a diene system. I have marked here, right? Diene system. Okay. If diene system is there, so while solving the problem, you must write it down. It is a diene system. It is a diene system, right? Diene system. And if diene system is there, we know that only one base value is there. So we know that the base value of diene system is how much? Base value should be 215 nanometer. That is the base value. Now look at the second letter. E stand for exocyclic double bond. Is there ring present there? No. So there is no question of exocyclic double bond. So remember, if then you write it down or you don't write it, it doesn't matter. Now look at third letter. A stand for Homo annular system. And as I already told you that if ring is present, in that ring only one ring containing as a both the double bond in the conjugation present in the same ring, that type of the system is called as a Homo annular system. It is not the open chain, it is not the ring, and therefore it is a open chain conjugated system, and therefore there is no Homo annular system present over here. So there is so you should not write that Homo annular. Now look at the fourth letter once again as a E. Again this second E stands for extended conjugation. What do you mean by the extended conjugation? During the explanation of calculation of lambda max by Woodward and the Fisher rule, I have explained each and every term clearly there. Do you remember that extended conjugation means in addition to the diene system, the extra double bond is present in the conjugation, then and then it is considered to be the extended conjugation. If it is far away from the diene system or it is separated by two single bond away from that diene system, then it is not considered to be a extra double bond. Remember this thing also very what we can call it is these are the prominent distinct you should remember while addition of. If you see this structure, look at here, this carbon carbon double bond, single bond, double bond, single bond and double bond means this double bond is in a conjugation, and this double bond is called as a extra double bond. In addition to the diene system, there is a extra double bond is present. That type of the extra double bond is called as extended double bond. If extended double bond is present, so in this system there is a extended double bond is present. Therefore, you should write it here extended double bond. And as we know that if extended double bond is present, how much to add? You should add 30 nanometer. So you add here 30 nanometer. That's it. Now the last letter is a S. S stand for substituent. There are the different substituents are present, but if we are here we are discussing about this structure only. So if you see here around all these three double bonds are in a conjugation, so you can mark it once again, and outside that how many ring residue or what you can call it as a alkyl substituent. So if you start from this side, there is a one substituent, you can mark it like this, second substituent, third substituent, fourth one, and this will be the fifth one. Here is a hydrogen, here also a hydrogen, here also has a hydrogen. Whatever alkyl groups are there, it is considered to be a substituent. Now how many substituents are there total? Just count it once again. 1, 2, 3, 4 and 5. There are 5 substituents. 5 substituents. If 5 substituents are there, then you can multiply by 5. So total becomes 5 into 5 is 25 nanometer, right? 5 into 5 is a 25 nanometer per centimeter. That's it. And now you can add it. So that is nothing but you can mark like this. So and here you write as a lambda max like this. So lambda max is nothing but as a wavelength, and which is a characteristic of that particular this. And now if you add 5 plus 5, 10, and 1 add here 2, 3, 4, 5, 6, 7. Here is a 7, and this 2 is a 2 you can add over there. So that is a 270 nanometer. If you solve like this, you will get as a 2 mark. For base value, 1/2 mark, and then rest of the thing you have to go on adding, you will get the mark accordingly. So this is the way of solving the problem based on by using Woodward and the Fisher rule. Now we have seen here are the 2 examples, right? Now let's see the one more example over here, so that we can see what the actual Woodward and the Fisher rule. Now is a third example we are trying to solve over here. So let's see third example. Now third example will be this one. See here, this is example number 3 I am writing over here, or let me properly draw either this side, or we can write this structure maybe as a like this, or not this way, or we can write this structure maybe as a like this. Double bond is here, one more double bond is here. So these are the 2 various way of representing the same structure, but you have to consider only as a one. So let's see here how to calculate the lambda max of the following compound. This is one of the compound written over here. So what is our first things to do? First, identify the diene, whether there is a diene system or some other system. If you observe this structure carefully, you will find here there is a diene system is present. Look at this, carbon-carbon double bond, single bond and double bond. Is there a diene system? So while solving it, you must write it. It is a diene system. It is a diene system, right? And as we know that di indicate as a 2 E and E suffix indicate as a carbon carbon double bond present in the same group. So that is, it is a diene system. Now if diene system is there, what is the base value for the diene system? Now you know that diene system has a base value is one and the only one, that is the base value should be 250 nanometer. Nanometer is a unit of wavelength. We know that 1 nanometer is nothing but as a 1 into 10 raised to minus 7 meter or 10 raised to minus 9 meter. Okay, base value is a 215 nanometer. Now what is the next indicate as a exocyclic. Does this structure contain exocyclic double bond? Yes or no? No. Look at here, ring is present, no doubt about it, but if you put a hand on a ring, you won't see any double bond outside the ring. There is no bond outside the ring, and therefore there is no question of exocyclic. There is no exocyclic present there. Now look at the letter number 3. H stand for Homo annular system. Does this compound contain Homo annular system? Yes, it has Homo annular system. Look at, only one ring is present and both the carbon carbon double bond present in the same ring. It is in the conjugation, and therefore it is a Homo annular system, and therefore you can write it as Homo annular system, right? Homo annular system. Homo annular system. And if Homo annular system is there, how much to add? You should add 39 nanometer, isn't it? 39 nanometer, right? Now Homo annular system. Now next one, what is the next letter suggest? E stand for extended conjugation. Does this molecule has extended conjugation? No, only 2 double bonds are there, and therefore no question of extended conjugation. There is no extended conjugation. Therefore, there is no need to write it here. So E stand for extended, just now we have seen, now is a substituent. Most of the students get confused while counting the number of substituent, and in this case, so we know that it is a diene system. We are marked like this or circled like this, and outside here is a one ring residue. Here also has another ring residue, means there are 2 alkyl type of the substituent, or it is termed as a ring residue. Means how many are there? There are 2 substituents, you remember here. 2 substituents, 2 alkyl substituent, or you can call it as a ring residue. And how many are there? 2 into 5. If 1 is there, we are adding 5. So here are 2 multiplied by 5 becomes as a 10, and therefore you can add as a 10 nanometer, right? So that's it. And then you can write here lambda max, and lambda max, it comes, you just add it, add properly. 9 plus 4, 14, therefore 4, and 1 you can consider here, add here 1, 2, 3, 4, 5 and 6, this is 6, and 2 means it as it is to 264 nanometer. That is the right answer. So if you solve like this, you will get as a 2 mark. Understood this one? So this is known as what we can call it as a, these are the problem we can solve like this. This is a problem number 3 we have seen over here. So now move on to the next problem. Now let's see the problem number 4 over here. Now I hope you all are expert now for solving such type of the problem. Now is a problem number 4 which I am writing over here. And let's see here problem number, this one, double bond, and here I am putting as a double bond like this. So this is a structure number, or here I am, okay, let it be. First one is a simple problem we are solving over here. Now, as we know that what is our, while solving such a problem, what is the first thing to do? First, you should recognize or you should identify the what type of the system it is. This structure consists dyne system, or this structure has dyne system. Look at here, carbon carbon, double bond, single bond and double bond, and therefore you can mark it like this. It is a dyne system. While solving the problem, you can call it is a dyne system. It is a dyne system, right? If you recognize this system, half of the work is done over here and half of the work remains. Now it is a dyne system, and we know that dyne system has only and one base value. The how much it is, the base value should be 250 nanometer. That's it. We know that it is a fixed value, base value is a 250 nanometer. Now see over here, E stand for exocyclic. Is there exocyclic double bond present? Yes. Look at, this is a ring. If you put hand on that ring, you can clearly see there is a one double bond outside the ring, and therefore one exocyclic double bond, one exocyclic double bond present in this system. If one exocyclic double bond is present, how much to add? You should add 5 nanometer in it, 5 nanometer, right? And this is the value for one exocyclic. If 2 is there, you can add a 10. If 3, you can multiply by 5, so 15. So now what is the next thing? H means Homo annular. Now, does this compound has Homo annular system? No. Look at here, Homo annular system. We know that the Homo annular system is both the double bond present in the same ring, which is in conjugation. That type of the system is known as Homo annular system. If you observe this structure carefully, you will not find such kind of the double bond in it. So look at, there is a dyne system is present, but the only one double bond present in the ring, one is outside the ring, and therefore this compound does not have Homo annular system. So there is no need to write it. Those are writing, they can add as a 0 nanometer. So doing that thing, so better way to do not write that one while addition as a 0. Now the next one, E means extended conjugation, and as we know that extended conjugation means what? In addition to the diene system we know that there are the two carbon-carbon double bond separated by one single bond. In addition to that diene system, if extra double bond is present, 3, 4, 5 like this, but that should be in a conjugation, then and then it is considered to be a extra double bond. But here in this case only two double bonds are present and they are separated by only single bond, and therefore it is a diene system. There is a no extra double bond here, so there is no question of extended double bond. Extended conjugation is not present here. Extended double bond is not there. Now the third thing, what is that? Last one is the substituent. And now how to count substituent, that also we know that. Now we already marked the diene system, and if you see here there is a one ring residue. Here second, on this there is no bond, here also no, therefore there are only two substituents are there, so you can write as a 2 substituent. If 2 substituents are there, then 2 into 2 it becomes as a 10 nanometer, right? So now you can write it down like this. Lambda max is equal, it becomes, if you add here 5 plus 5, 10, 0, 1 is there, 1, 2, 3. So 3 and 2, you can write it down as it is 2 nanometer. So this is the answer of this question. Understood this one? So this is about the, what we can call it as a base value, or this is calculate the lambda max of the following compounds. By using this way we can easily solve the problem based on it. I think with this, let us remaining problem we will solve tomorrow, so that we can understand the better way the diene system. I think with this let us stop today here. Remaining we will discuss in our next lecture, means tomorrow's lecture. Let's wrap up today's lecture here. Thank you. Have a nice day.